Here we are back in West Virginia. Don't you just love it? Okay, so it is time for Joke of the Day because I love Joke of the Day. Are you ready? Let's do it. So where do crayons go on vacation? You know, crayons that kids color with. Where do crayons go on vacation? Well, Colorado. Colorado, not quite West Virginia, but Colorado. Anyways, let's brighten ourselves and let's take a look at factoring by grouping. So with factoring by grouping, it's kind of the idea of common monomial factoring. And recall that common monomial factoring, what it does is it takes a look at every single term and says what's common to every single term, and it divides out that largest common factor and then writes down in a parentheses what's left once the division is done. Well, sometimes that GCF, that greatest common factor, can actually be a binomial. Now this is going to feel very weird, so just stay with me and I'll walk you through it. So in these three examples, it doesn't look like what we're used to seeing. We're used to seeing, say, 3 terms, 2 terms, or even possibly 4 terms sitting here. No parentheses anywhere. But suddenly, I've got some parentheses in here, and that's kind of messing up my rhythm. So, what we need to understand is that terms are separated by addition and subtraction. Within a term, you have multiplication. Within a term, you have multiplication. So this is going to feel very weird, but bear with me. I have what I call one funky looking term right there. Because even though I've got addition right in here, it's technically s squared times parentheses. And a lot of times I put my hand over top of the parentheses so that I don't confuse myself. S squared times parentheses, that gets that whole that addition out of there that's messing me up. But now that I see it this way, that it's just s squared times parentheses, that's multiplication. And remember, within a term, I have multiplication. So then I've got another funky looking term back here. It feels weird, but it's 2, again, times parentheses. And again, I'm going to put my hand over top of the parentheses so it doesn't confuse me. 2 times parentheses. There's the multiplication within the term. So now that I've boxed off this term and boxed off this term, take a look at the 2 boxes. What do you notice that's common to the 2 boxes? Well, absolutely, they both have the same parentheses in them. So recall that common monomial factoring said, I'm going to divide out what's common to every single term. I'm going to do the same thing here. I'm going to divide out what's common. It just happens that what's common is a binomial. So I'm going to take that common binomial, that r plus s, and I'm going to divide it out of each one of these terms. Now recall, what I do is I'll do that division and I'll write down what's left. So when I divide that r plus s out of here, I'm left with just an s squared. When I divide the r plus s out of here, I'm left with just a 2. And then recall what we did with common monomial factoring is we said whatever we divided out, we let it sit out front because we don't want to change the value, we only want to change the looks. So that r plus s is going to sit out front. Now, I have to be very careful because recall, I should be able to distribute this through and get back to the beginning. The only problem is when I distribute here, exactly what am I distributing? Yes, only the s. But I really need to multiply the entire r plus s to what's inside the parentheses. So how do I signify that all of the r plus s is going to be multiplied? Absolutely. I need to put a parentheses around that r plus s. Now this feels kind of weird, but this is the factored form. Because factored form means I simply have things that are multiplied together. I have parentheses times parentheses. Granted inside is a plus, granted inside is a plus, but really it's just parentheses times parentheses. Here's the 2 things that are being multiplied together. So this is my factored form. Now, recall that I should be able to do this multiplication and get back to the beginning. So when I go to multiply, I'm going to do, now what would you do with this? Exactly, that's going to be FOIL, the extended distributive property. So when I multiply r times s squared, I'm going to get an rs squared. When I multiply r times 2, I'm going to get a 2r. When I multiply s times s squared, I'm going to get an s to the third. And when I multiply s times 2, I'm going to get a 2s. Now, what's written in blue looks nothing like what's written up here. Now, notice though, there's no common terms that I can combine, so this is it. But this looks nothing at all like what's written in black where I started. However, notice here what's written in black. If I would take that s squared and distribute it through this parentheses, what's s squared times r? Absolutely, rs squared. Bam, right there. What's s squared times s? Absolutely, s to the third. Bam, right there. And when I take this 2 and distribute it through, what's 2 times r? Absolutely, bam, 2r. And 2 times s? Bam, right there. It's all there. So this is, in fact, the correct factored form. This is what we call expanded form. I'll go ahead and write that down. Expanded form. This is what we call factored form, because remember, factors are things that are multiplied together. This is a couple of parentheses being multiplied together, so this is factored form. This is just a little mix of both. It's not quite expanded form, it's not quite factored form, it's what I call kind of, not very good factored form, or halfway factored form. But the bottom line is, when the directions say factor, I want it to look like this, where I have a couple of parentheses being multiplied together. Or, at the very least, something times something else. And so this is my factored form. So, let's take a look at this one. Here we go again with this idea that I've got a very funky looking funky looking term sitting right there, because it's 7x times parentheses. Right now I kind of don't care what's inside the parentheses. It's just 7x times parentheses. There is my quote term. Here is the subtraction separating those two terms. So back here is my other funky looking term. So now that I've got them both boxed off, what's common to both? Absolutely, that x plus y is common to both. So I'm going to divide out that common x plus y. I'm going to divide it out of both of those terms, and I'm going to write down what's left when I do that division. When I take that x plus y out of here, I'm left with a 7x. When I take the x plus y out of here, now notice, a negative x plus y divided by an x plus y, they cancel. They cancel to be a what? A 1. They don't cancel to be a 0, they cancel to be a 1. But it's negative divided by positive, so it's a negative 1. Now recall, I'm going to write down in parentheses what's left whenever I do that division out. So that x plus y is going to slide out front. But remember, I want the entire xy to be multiplied to this 7x minus 1. Here's my answer in factored form. And remember, I can double check this, because x times 7x is going to be a 7x squared. X times negative 1 is a negative x. Y times 7x is a 7xy. And y times negative 1 is a negative y. Now there's nothing here that I can combine, so let's double check and make sure we can get that, because that doesn't look like it's getting me back to the beginning. However, 7x times x is 7x squared, bam, right there. 7x times y is a 7xy, bam, right there. Distribute this negative through, negative times x is a negative x, and negative times y is a negative y, bam, it's all there. Here's my expanded form, but I want to factor, so my factored form is sitting right here. All right, one more of this. So here is my funky looking term right here, because it's 9x squared times parentheses. So there's the two things that are being multiplied together. And then back here, whoa, wait a minute, there's no parentheses there. It looks like I have two terms. However, notice that what's inside the parentheses is a 7x plus 2. That's exactly what's sitting right here. So if you really need to, you could put a parentheses around this, or you could just let it sit there, because right here, there's the other box. And so now as I'm looking at both of the boxes, I'm going, oh, okay, they both have a 7x plus 2 in common. So I'm going to divide out that common 7x plus 2 out of both of these funky looking terms. When I divide it out of here, I'm left with a 9x squared. When I divide it out of here, once again, they cancel out, but they do not cancel to be a 0. They cancel to be a 1. And I'm going to write down over here what I divided out. That's 7x plus 2 that was divided out. And again, I'm going to put a parentheses around that 7x plus 2 to show not just the 2 is going to get distributed through here, all of this is going to get distributed through. And so therefore, when I go to check it, 7x times 9x squared is going to be a 63x to the third. And then 7x times 1 is just a 7x. 2 times 9x squared is an 18x squared. And then 2 times 1 is 2. There's nothing here that I can combine, but let's double check it when we expand this. 9x squared times 7x squared is going to be my 63x to the third. Bam, right there. 9x squared times 2 is going to be my 18x squared. Bam, right there. And then here's my 7x, and here's my 2. Bam, bam, bam. It's all there. Okay, so hopefully you can see a common binomial can be your GCF, and you can divide that common binomial out. This idea is going to carry us into 4 polynomials and being able to factor 4 polynomials. So let's take a look at some examples of these 4 polynomials. Now recall, 4 polynomials means you're going to have how many terms? Yeah, mathematicians are not creative. 4 polynomials means 4 terms. So take a look at the fact that I've got 4 terms here. I need to make it look like what we just did, where we have that common parentheses within each of those funky looking terms, within each of those boxes. The way that I'm going to make that happen is I'm going to pair up a couple of the terms. So say, for instance, I pair up these 2 and I pair up these 2. Now what I'm going to do is I'm going to do that common monomial factoring in this pair. And I'm going to do common monomial factoring in this pair. And then that will create that funky looking term like we saw back here. Funky looking term, funky looking term. I will have a common binomial, a common parentheses. I'll be able to divide it out. I will be able to take myself right back to here. So sometimes you need to factor on those pairs to find that common binomial. So like I said, let's pair these 2 up and do the common binomial factoring, or not binomial factoring, sorry, common monomial factoring on just these 2. What's common to the x squared and the 7x? Yes, an x. So I'm going to divide that common x out, and I'm going to write down in parentheses what's left. Divide that common x out of here, I'm left with an x. Divide that common x out of here, I'm left with a 7. Now I'm going to do the same thing right here, and I'm going to say what's common to both of those? Yes, a 4. So I'm going to divide that 4 out, and I'm going to write down what's left. Now when I divide the 4 out of here, I'm left with, be very careful, a negative x. When I divide the 4 out of here, I'm left with, be very careful, a negative 7. Now, recall this idea of that funky looking term. So here's a funky looking term where I've got that x times that parentheses. And here's a funky looking term. Now notice I divided out a positive 4. So here's the other funky looking term right here. Whoops. Right there. But recall that in order to drag out that parentheses, they have to be identical. I have a positive x, positive 7, a negative x, negative 7. They're not identical. And if they're not identical, you cannot divide them out. So is there an adjustment that I can make to make them identical? Well, certainly. Some of you back in the beginning were saying, why are you not taking a negative 4 out of there? And you're absolutely right. Because when I divide this by a negative 4, I get a positive x. When I divide this by a negative 4, I get a positive 7. Now within the boxes, I do have those same common binomials. So that common parentheses, I'm going to divide out, and I'm going to write down what's left. That common x plus 7 is going to come out, and then I'm going to write down in this parentheses what's left when I do that division. Divide the x plus 7 out of here, I'm left with an x. Divide the x plus 7 out of here, I'm left with a negative 4. And at this point, I have my factored form. Because remember, factored means things that are multiplied together. This is parentheses times parentheses. There's the 2 things that are being multiplied together. Here, this is not really factored form. Sure, it's x times parentheses. Sure, it's 4 times parentheses, but see, I'm subtracting the 2. That is not factored form. That's what I call crappy factored form. It's not very good factored form. This is real factored form. Parentheses times parentheses. Now recall, I should be able to check it. If I FOIL this, I better get back to the beginning. Well, x times x is x squared. X times negative 4 is negative 4x. 7 times x is 7x. And 7 times negative 4 is a negative 28. I do, in fact, get back to the beginning, so I know that that's the correct factored form. Okay, let's try a few more of these just to make sure we get really good at it. So like I said, for polynomials, what we're going to do is we're going to pair up a couple of terms. So we'll put these together and we'll put these together. And then we're going to do that common monomial factoring on each pair, hoping to create that funky looking term and another funky looking term that have the same parentheses, and we can divide out that common parentheses. So as I pair these up, what's common to both? Absolutely, that x squared can be divided out of both of them. Divide an x squared out of here, I'm left with x. Divide an x squared out of here, I'm left with 6. Now as I look at these, what's common to both? Aha, we're getting smart. We're saying, sure, we can take a 2 out, but we're going, I bet we take the negative with it, because that's what we saw back here. Now, when I divide this one by negative 2, I'm left with x. Negative 12 divided by negative 2 is a positive 6. So there are, in fact, those funky looking terms that I was looking for. One right here, and then one right here. Notice that within the 2 boxes, I do have those common parentheses. The parentheses have got to be identical in order to pull them out. So I'm going to pull that common parentheses out, that x plus 6, write it in a parentheses, and write down what's left. Take that x plus 6 out of here, I'm left with an x squared. Take the x plus 6 out of here, I'm left with a minus 2. There's my factored form. Double check to make sure that you're right. Just distribute it through, FOIL it. X times x squared is x to the third. X times negative 2 is a negative 2x. 6 times x squared is a 6x squared, and 6 times negative 2 is a negative 12. So it is, in fact, right. All right, let's do one more, and then I'm going to kind of stretch our brains a little bit and do something a little bit more complicated. So once again, I'm going to pair things up, pair up these two, and pair up these two. And then I'm going to look for what's common to both of the pairs. Here, I can take an x out of both. When I take the x out of here, I'm left with a y. Take the x out of here, I'm left with a negative 1, because remember, I'm dividing. I'm not literally taking the x out, leaving me with nothing. I'm dividing. When I take this xy and divide it by x, I'm left with a y. X divided by x is a negative 1. Here, what's common to both is a 7. When I divide this by 7, I'm left with a y. Once again, I'm not just taking the 7 out, I'm dividing. Negative 7 divided by 7 is a negative 1. Aha! There's those funky looking terms that I was looking for. One right here, and then one right here. Notice that within each of those, they both have a common parentheses, that y minus 1. So I'm going to divide that y minus 1 out, let it sit in a parentheses, and write down what's left. Take that y minus 1 out of here, I'm left with x. Take that y minus 1 out of here, I'm left with a 7. There's my factored form. And if I FOIL it, y times x is xy. Y times 7 is a 7y. Negative 1 times x is a negative x, and negative 1 times 7 is a negative 7. It does, in fact, get me back to the beginning. Okay, so let me show you a couple of a little bit more challenging examples. I'll go ahead and erase this. Enjoy that lovely West Virginia scenery behind me as I clear off this board, which is not clearing well at all. Okay. All right, so example number 4, I've got a 10x squared minus a 12xy plus a 35xy and minus a 42y squared. And again, I have a 4 polynomial. When I have a 4 polynomial, the easiest way to factor it is to pair these up and pair these up. So I'm going to look at each pair and I'm going to try to find what's common to both and divide that common thing out, hoping I can create that common parentheses in each of those funky looking terms. So as I look at this one, both of them are divisible by 2 and an x. So I'm going to divide that 2x out of both of them. Divide this by 2x, 10 divided by 2 is 5. X squared divided by x is just an x. Negative 12 divided by 2 is a negative 6. And then when I divide that y out, I'm left with divide the x out, I'm left with a y. Now here, what's common to both? Well, I can divide both of them by 7. Plus, I can divide a y out of each one of them. Now when I divide this by 7, I get a 5. And then the y's will cancel, I'm left with an x. Divide this by 7, I get a negative 6. And when I divide that y out, I am left with 1y. So I have created those funky looking terms, one right here, and then one right here. Now as I look at each one of them, notice they both have that common parentheses. So I'm going to take that common parentheses out, that 5x minus 6y. And when I take it out of here, I'm left with 2x. And I take it out of here, I'm left with 7y. So there's my factored form. And notice, yet again, I can distribute and get back to the beginning. 5x times 2x is 10x squared. Bam, there it is. 5x times 7y is a 35xy. Bam, there it is. Negative 6y times 2x is a negative 12xy. Bam, there it is. And negative 6y times 7y, sure enough, bam, 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 negative 42y squared. So this is the correct factored form. Now, one more example, because this one does something pretty interesting. Because notice that what we've done all along is we said, okay, a 4 polynomial means that we're going to pair things up, and we're going to pair the first two, we're going to pair the back two, and that common parentheses always miraculously shows up. So when I pair up these two, and I pair up these two, and I look at this and I say, what's common that I can divide out? I can certainly divide a 2 out. And I'm left with an xy minus 3, because 6 divided by 2 is 3. Now here, oh, nothing common that I can divide out. So there is this notion that you can reorder your terms. Because remember, addition is commutative and associative. So you can reorder your addition. Granted, this is subtraction, but look at it as the name tag. The sign in front's the sign that goes. So if that's the name tag to the 6 and this is the name tag to the 3y, and I keep the name tag with it, then I can put those in any order that I want. Because when you go to the meeting and your name tag's on the front, you can sit over here, you can sit over here, or over here. As long as you keep your name tag on you, then I know who you are. So if that's the case, maybe I can reorder these. So what if instead I put the 2xy with, say for instance, that negative 3y in the back. And let's put that negative 6 with this 4x. Maybe that will work. So instead what I'm going to do is I'm going to pair up these two, and I'm going to pair up these two. So here, what's common? Yes, that y is common. And when I take the y out of here, I'm left with 2x. When I take the y out of here, I'm left with negative 3. Now on these, what's common? Certainly I can divide a 2 out of each one of them. When I divide this by 2, I'm left with negative 3. When I divide this by 2, I'm left with 2x. Now it's going to feel very weird, but here is that funky looking term. Here is that funky looking term. Notice that the parentheses don't feel the same, but they are. Because this is a positive 2x, positive 2x. Negative 3, negative 3. The parentheses really are the same. So I'm going to factor out, divide out that common parentheses, and I'm just going to go ahead and write it as a 2x minus 3. And then I'm going to write down what's left when I do the division. Take it out of here, I'm left with y. Take it out of here, I'm left with 2. And there it is in factored form. Notice that when I distribute, 2x times y is a 2xy. Bam, there it is. 2x times 2 is a 4x. Bam, there it is. Negative 3 times y is a negative 3y, and negative 3 times 2 is a negative 6. Gets me back to the beginning. Now, when I was rearranging these, some of you might have been going, wait, why are you taking this and dragging it all the way back here? Why didn't you put these two together? Quite frankly, it's because I didn't quite know that it was going to factor beautifully when I did that. So what if I do put the 2xy with the 4x? And then I put that negative 6 with the negative 3y. And so therefore, what if I pair up these and I pair up these? Now if I pair these up, what's common that I can divide out? A 2x. And when I do, I'm left with a y plus 2. Here, if I pair these two up, what's common? A 3, and we're all figured it out. I'm going, whoa, they both have a negative. Probably better take that negative out with that 3. Divide this by negative 3, I'm left with 2. Divide this by negative 3. Remember, negative divided by negative is positive. It's a positive y. And so here are those funky looking terms. One right here and one right here. And notice that both of them have that y plus 2 in common. Granted, it's y plus 2, 2 plus y, but it's a positive y, positive y, positive 2, positive 2. They are the same. So I can take that common y plus 2 out. When I do, I'm left with a 2x minus 3, which is exactly what's right here. 2x minus 3, y plus 2. even though when I divide it out this way, I would have a y plus 2 out front, and then I would have a 2x minus 3 in the back. Remember, multiplication is as well commutative and associative. So you can reorder and regroup your multiplication. So in other words, I could have 2 times 3, which is 6, or I could switch it around this way and do 3 times 2. What's 3 times 2? Still 6. So my multiplication I can write in any order that I want. I'm going to get the same product in the end. So since it's parentheses times parentheses, I could put this parentheses in the front and this parentheses in the back, or I could switch them up. So my 2x minus 3 could sit in the front, or my 2x minus 3 could sit in the back. Same thing here. The y plus 2 could sit in the back, or it could sit up front. Either way is perfectly fine. So I hope this helps you with the idea of factoring 4 polynomials, as well as this concept of factoring by grouping. Because factoring by grouping can not only help you factor 4 polynomials, it can also help you to find a common binomial within some very strange looking terms. It also can help you with factoring trinomials. So I hope this helps. Have a fantastic day.